Hey, what's going on, everybody? The Theta Edge Cloud is going to launch on May 1st. This is perfect timing. Let's dive in a little bit to this. I'm just going to have a read along, so check this out.
Delivering higher performance with better hardware and software specs, with a number of partners launching subchains in 2023. Edge nodes are now also compensated with partner TNT 20 tokens for various video and OWL tasks. Theta Edge Network, with its more than 10,000 monthly active nodes, has become a key differentiator compared to other L1 blockchains. The Theta Edge Cloud is the next generation technology that builds on the Theta Edge Network and Theta Metachain, significantly extending and generalizing its capabilities to become the first hybrid cloud computing platform that is built on a fully distributed edge architecture. This journey began in April 2021, when Theta filed its patent for edge computing platform, supported by smart contract-enabled blockchain networkone, which was granted in September 20,232. Figure 1. A global distributed network formed by Theta Edge nodes serves as the backbone infrastructure for the Theta Edge Cloud. Active Edge node 6,901, Guardian node at 3,000, Validator node 29. Medium.com/Theta Network/Theta awarded us patent for edge computing platform supported by smart contract enabled -8990 248 2 imagepubs.uspo.gov/search public/print/download PDF/. 2. Market opportunity. Theta is introducing the first hybrid cloud edge computing platform that can leverage thousands of edge CPU and GPU nodes worldwide, in addition to a hosted, cloud-based distributed architecture. This opportunity is motivated by three major industry trends. 2.1 Increasing video demand globally. The amount of video content and related data continues to grow due to the increasing popularity of social media platforms and rising internet connectivity, particularly in less developed regions. Video data traffic globally is also driven by demand for higher resolution 4K, 8K and higher resolution videos. According to Fortune Business Insights, the global video streaming market size was valued at $455.5 billion in 2022 and is projected to grow more than fourfold to over $1.9 trillion by 2030. This trend drives an increasing need for video encoding, transcoding and delivery services, as well as global visualization and 3D rendering services for various industries, including manufacturing, healthcare, construction, education, and real estate sectors. 2.2 Adoption of OWL across industries and applications. The market for artificial intelligence is expected to grow over 10 times in the next decade. Adoption of OWL applications across verticals from travel to manufacturing. Every 4/14 chains, marketing, product making, research, analysis, and more are fields that will aspect of OWL within their business structures. The release of ChatGPT in the generative OWL market in 2022 was a significant catalyst for end-user adoption of OWL and chatbots. The overall OWL market is estimated to grow from $142.3 billion in 2022 to over $1.85 trillion by 2030, according to Statista. This trend drives the need for CPU and particularly GPU compute resources to prototype, train, fine-tune, and serve OWL models. 2.3 Infrastructure compute services. New bite-sized infrastructure compute services to support video, media, and general OWL computation tasks have become increasingly more important as computation data grows exponentially by 100 times. For example, to fine-tune and train domain-specific large language models, LLM, and generative text-to-image and particularly text-to-video OWL now requires large amounts of data, which makes today's centralized systems cost prohibitive. The ability to paginate or distribute the workload of vector databases, for example, that store data in a multi-dimensional space with each dimension corresponding to a specific feature, or 3.1 Product vision. 3. Theta Edge Cloud overview. Attribute is groundbreaking. Vector databases are ideal for similarity search applications like natural language processing, computer vision, and recommendation systems. They complement generative OWL models well and provide an external knowledge base for generative OWL chatbots to ensure information accuracy. 4/14. Theta's product vision for 2024 to 2025 is to deliver a fully distributed hybrid cloud edge MPUN platform that caters to the diverse needs of a wide range of users. This platform will be designed to meet the demands of Global 1000 corporations seeking scalability and performance, and the flexibility for high-growth small and medium businesses, SMBs, researchers and developers at 3-5 times cost savings. For example, for a network of high-end NVIDI of 4,090 seconds on a per GPU hour cost basis, Theta's hybrid cloud edge computing network should be to 1/3 of the cost compared to Microsoft Azure, AWS or Google Cloud.
I'm going to pause it right there. If you want to go back and listen to that again, I actually listened to it like maybe 2 or 3 times, and you start to fully grasp really what the edge cloud is about, and more so what Theta is about. So yeah, I'm just doing this AI voiceover. It's not the best AI voiceover, but it's better. His voice is definitely better than mine. So I'm going to keep going. Let's go.
In contrast, SMBs, researchers, and community-driven projects often strive for a more delicate balance between cost and service levels. They are often constrained by budget limitations. Large enterprises, SMBs, and individuals have distinctive needs. Large enterprises typically require reliable service with service level agreements, SLA, such as guaranteed uptime of at least 99.999%. These organizations operate on a massive scale, serving tens or even hundreds of millions of users, and any downtime or performance issues can have significant business consequences. Thus, reliability, robustness, performance, and privacy are the most important considerations and typically overshadow concerns about cost, making them inherently cost-sensitive. Reliable services are important, but they may be willing to make calculated trade-offs between price and service levels to maximize their resources. This flexibility allows them to allocate resources efficiently and prioritize aspects that allure strategic goals. Theta Edge Cloud's flexibility addresses the needs of any type of view, customizing its usage to serve large enterprises, SMBs, and community projects. Ali 5/14. 3.2 Supported computing tasks. The Edge Cloud platform is designed to support generic containerized compute tasks, as it implements a virtualization layer where users can run any container on the network. The strength of the virtualization layer lies in its capacity to cater to a myriad of computing needs, all with a unified interface that bridges differing requirements, delivering a robust, scalable, and adaptable infrastructure. Any computation task can be run on this platform as long as it can be containerized, whether it involves complex data analytics, artificial intelligence, video processing, or even specialized scientific simulations. This flexibility offers a dynamic environment where users can harness the power of containerization and distributed edge and cloud computing resources to optimize, deploy, and scale their workloads with ease and efficiency. 4.14. Computing tasks that can be handled by the Edge Cloud platform include, but not limited to, the following: media and entertainment. As already implemented in the Theta Video API platform, a decentralized edge network platform can handle resource-intensive media and entertainment tasks, such as video, encoding, live stream transcoding, and bandwidth. Time required to find the best model hyperparameters. Artificial intelligence. Our workflow is fairly complex and involves many computational steps that are ideally suited for Edge Cloud's Distribute D platform. A typical W starts with using Jupyter Notebook for data exploration, where data scientists 5/14 and pre-process the dataset. The next step involves hyperparameter tuning architecture search, where models are optimized for better performance. Subsequent steps include model training, where the chosen deep learning model learns from the data. If needed, fine-tuning and alignment follow, involving further adjustments and iterations to improve the model's accuracy. Finally, when the model is ready for real-world use, it's deployed for serving or inference, sharing efficiently. The Theta Edge Cloud platform will take this capability to the next level. Whether it's encoding video content for multiple formats, transcoding to optimize streaming quality, or rendering complex 3D visual effects for movies and animations, the Edge Cloud platform will provide the scalability and reliability required by the largest media companies. 5/14. Scientific research. Complex scientific simulation jobs include, for example, weather forecasting, climate modeling, astrophysics simulations, chemical reactions, malada, structures, and material properties research. These simulations can also 6/14. Genomic datasets, conduct DNA sequencing, and perform complex bioinfor for genetics research in the biomedical field. They require massive computation. 2. AL inference applications include generative text-to-image, text-to-video, large language models, LM, and other custom models. This involves setting up an infrastructure to make predictions accessible to end users or other systems, often through APIs or endpoints. All these tasks, from Jupyter Notebook to model serving, can be easily containerized. In particular, hyperparameter tuning requires the exploration of multiple combinations and configurations, a computationally intensive process that benefits significantly from parallelism. These types of tasks are perfectly suited to run on a highly distributed edge network, where the ability to distribute these computations across multiple nodes or devices can greatly expedite the optimization process and reduce the resources to model physical, chemical, and biological phenomena accurately. Using a hybrid of edge and cloud resources, Theta Edge Cloud can direct simulation jobs to the best combination of compute resources to efficiently complete the task. 3. Financial modeling. In the financial sector, complex models are often used for risk analysis, high-frequency trading, and Monte Carlo simulations to assess investment strategies and market behaviors. These applications play a pivotal role in the industry to analyze and optimize investment strategies, market trends, and risk management. The computational demands of these financial models can be substantial, requiring access to high-performance computing resources capable of handling large-scale data and intricate calculations in real time. The Edge Cloud platform's distributed, highly parallel architecture is ideally suited for addressing these types of financial computational needs. 4. Edge Cloud architecture. To realize the product vision discussed above requires a flexible and scalable hybrid cloud edge computing architecture, as shown in Figure 4.1 multi-shard architecture. The key design principle is to divide the edge nodes into multiple shards, each type catering to different business requirements. For example, enterprise computation tasks need to run in a private and secure environment versus non-sensitive NFTs, media files, and generative OWL tasks can be executed in a public environment. Other considerations include node reliability, robustness, and performance. Enterprise customers also have more strict SLAs, so those tasks are better run on more reliable nodes. Figure 2 outlines 3 types of shards technically. Community shards. The workers of this type of shard are community nodes running on laptops and desktops, which typically do not have a public IP address. For the worker nodes to communicate directly with each other, a software-defined network, SDN network, can be configured. This type of shard is typically less performant, reliable, and robust. However, they are optimal for smaller, faster, and highly parallelizable jobs, e.g., OWL hyperparameter tuning, and tasks like OWL inference and video encoding with built-in fault-tolerant mechanisms. In the long run, community nodes would also encompass a wide range of devices, including smartphones, smart TVs, and distributed lot devices. 4.2 Shard management. To effectively coordinate the shards and the worker nodes, a hierarchical worker node management approach will be implemented. A coordinator cluster oversees and manages the entire infrastructure, allowing for infinite scalability and fault tolerance. It is in charge of intelligently assigning and routing a compute task to the most optimal cluster node. Manage shards. The workers of this type of shard are nodes hosted by Theta Labs in the cloud environment. The worker nodes can communicate directly with each other through a private network. A managed shard is more reliable and ideal for workloads like OWL model training, Jupyter Notebook, and tasks with strict SLA requirements from enterprise customers. Data center partner shards. These data center workers are nodes run in partner data centers. The worker nodes can communicate directly with each other and can communicate with the master cluster through public IPs. Data center shards run by crypto mining businesses, regional cloud service providers, and other partners are also more reliable and equipped with better hardware and software, suitable for workloads with certain SLA requirements. A worker node actually runs the Theta Edge node client software. This will be consistent across all shards, except for its hardware specifications and performance. For example, in community shards, worker nodes are composed of lower and mid-tier CPUs and GPUs on laptops, PCs, smartphones, and other lot devices. By contrast, in managed shards initially operated by Theta, worker nodes will incorporate high-end NVIDIA GPUs, such as Tesla ASAS, with up to 312, 600, and twin-fourths FP16 T-flops, TE with 65 FP16 T-flops, and others. 4.3 Task Assignment, 5 Singh et al., a dual-agent scheduler for distributed deep learning jobs on public cloud via reinforcement learning, ACM CKDD 2023. 6. Compute tasks are initiated by Edge Cloud customers and partners through a user-facing dashboard or API for developers. The task metadata is passed to the coordinator cluster, which then decides which shard and worker nodes the task should be assigned to. In order to intelligently optimize the distribution of tasks, an efficiency score will be assigned to each worker node across the Edge Cloud network, a function of various factors. Efficiency score: FEF job type, price, latency, availability, computing capacity, fairness. Given a particular computing task, the coordinator will compute in real time and route the task to the node and shard with the highest efficiency score. More advanced technologies like reinforcement learning could also be adopted to determine the task assignments and improve overall system efficiency. We have conducted preliminary research on this technology and published our research findings at the prestigious ACM CKDD conference. Within each shard, a master cluster manages and orchestrates that shard instance, consisting of an orchestration control plane providing an API server, scheduler, and other control components. The master cluster will also implement multiple master nodes to ensure fault tolerance. User admin dashboard, Figure 3. The task assignment process. A customer initiates the compute task through the user-facing dashboard or API, which is then assigned by the coordinator cluster to a worker node and shard with the highest efficiency score. 5. Additional considerations. 5.1 Support for third-party client integrations. 4.4 Token rewards for edge nodes. Edge nodes are rewarded for compute jobs they perform with either TFUEL or TNT20 tokens issued by Theta partner projects built on the Theta Metachain. The coordinator will implement a reward module to calculate job rewards based on various factors, including but not limited to 1. Job type, 2. Correctness of the computation results, 3. Job completion time, and 4. Resource usage of the edge node. To prevent malicious edge node operators from gaming the system for token rewards, the coordinator will check the correctness of the computation results. Verification of correctness can be accomplished through the implementation of any of the following approaches. Zero-knowledge-based correctness checks. Zero-knowledge technology allows the public to check whether a task is completed as prescribed without revealing any specific details about the task itself, and without disclosing the actual data or process involved. This is valuable for privacy and security, as it ensures that sensitive information remains confidential while still confirming the accuracy of the work performed. Cross-check. Given the vast parallel computing power of the Edge Cloud platform, it is possible to assign the same jobs to multiple nodes and cross-check the results. THETA is server-side random verification. The coordinator can also randomly sample a certain percentage of jobs and rerun those jobs on trusted machines. By comparing the result, the coordinator can evaluate whether the result uploaded by a worker node is valid or not. FedML, tap into Edge Cloud and federated learning. Deployment, mobile devices. The FedML client completed in November 2023. For the FedML jobs, a few third-party AL clients, including FedML and THETA, in addition to native video encoding, transcoding, and delivery clients. Collaborated with FedML earlier on a related research project, which resulted in a research paper published at the IEEE DAPS 2023 conference. With recent advancements in zk-SNARK and zk-ML, these proofs can be made very short and fast to verify. As these technologies mature, A worker client can potentially leverage them to generate succinct correctness proofs for the computation jobs assigned, and upload the proofs along with the results to the coordinator. The coordinator then verifies the proof and rewards the worker only when the proof is valid. On this front, Theta Labs. As an open network, the Theta Edge Cloud platform will support third-party compute client integrations in addition to first-party workers. Currently, the Edge node software has incorporated third-party, over time many more, and serve as important building alternative ways for Volve, continue to and utility of Theta Edge Cloud. First-party client, Edge Cloud, worker client, a blockchain owl based in many tasks. In Figure 4, Theta Edge node supports both first-party and third-party clients. The Edge node software also implements a client scheduler which launches and coordinates various clients. Biocates et al. Proof of contribution, based design for collaborative machine learning on blockchain IEEE DApps 2023. TFUEL. Earn.c. Next generation healthcare platform, enabling the use of massive biomedical datasets for research while preserving individual privacy and ownership of. With Theta Edge Cloud, the Levita platform connects individuals. 5.2 distributed storage roadmap implications, years, and accurate training query the source video will account. Compute, stored, it cannot files because such as digital, cases, the data, immutable storage, traditional media files require immutable storage, immutability. Is a cloud service for LLMS and AMP, generative OWL. With the Fed ML client integration, users can the Theta through the Fed MLI portal and launch complex model training on decentralized GPUs, multi-clouds, edge servers, and reward system integration with Theta Edge nodes was. The Edge nodes are currently compensated with TFUEL rewards. Data, through its integration with data miners, such as pharmaceutical and research companies, to participate in new drug trials and treatments, gain insightful genetic information and latest research findings based on their clinical needs. Launched in August 2023, Theta Edge nodes earn Levita token rewards for healthcare OWL model training. Node among distributed storage is an integral part of the new Theta Edge Cloud platform. While Theta Edge Store Alpha release offers storage service in the form of a KV store, in the Edge Cloud storage could take different forms. Below are context. Different types of use in a compute-intensive scenario. Vector file, Theta Edge Cloud minimize technical. A. Use cases, while in the process, database 4 be loaded. Stoked TFUEL, 500,000, no. Edge Cloud as HS. Needs, for storage. Rewards will include, when, performance generative OWL, community, Theta, Edge node beta. Box 12,000. 345, 456,789 block, 2,123. 456 pairs, temporal storage. This use case requires retaining data in memory or disk for short durations. For example, the training data required for our models. This enables quick-off compute-intensive jobs, access to critical information, enhancing the efficiency, including machine learning and data analysis. Storage. The Edge Cloud storage system can be used to host distributed persistent databases, which requires persistent as well as updatable storage. One such type of database has gained significant traction among the machine learning community in recent is the so-called vector database. It is ideal for applications that require fast similarity search, such processing, and computer vision models to retrieve external knowledge based on similarity searches. Release 2. Enable and community centers. This allows existing product, open node wallet, release 1, token incentives, and, in a controlled environment customers. 17 will enable Theta Labs, worker, pending, 200, bind pending, 125.75. Payouts, over min threshold, and center first week off a month, will release hosted by unlocked wallet. This elite node status, and earn boosted there is limit and bonus reward multipliers. Hosted with PUS, stake TFUEL. 6. Product launch strategy, rollout in 3 releases. While implementing Lavita subchain. 2. EEN can at that are batched. Risks currently. Distributed service. Cases for distributed storage. Launch. Will be integrated into the Theta Edge Cloud platform to improve system robustness, fault tolerance, and offer users to access the Edge Cloud computational power. As these clients add more features, they will further enhance the overall functionality and listed elite coordinator cluster node will need above are toe-bolted, tampered with, or deleted. They represent ownership or provenance, art, collectibles, or other virtual assets. O Release 3, Role Community, Cluster Routes Incoming Job, Immediacy, Performance, 6.1 Release 1 Overview, Cloud, Resources, Out, Working, Any, Blocks. And for example, select, via, Edge, Clients, Cloud, Elite, offering, earning TFUEL and nodes, building Edge Cloud service businesses, over 10,000 monthly, partners, members, external. Fully, Theta Edge node, then, TFUEL, the additional well, Fed ML client, 7, conclusion, rewards, utilized in, compensation, and a Edge, lock, with the launch, or video, while performing a compute. Needs to access and load the, during model inference, it might need to, case of video transcoding, the original, run transcoding algorithms, our system design. A temporal, persistent, or immutable mode, where for the associated storage, utilize.
All right, guys, I'm going to end it right there. Basically, this is a PDF form. It's called Introducing Theta Edge Cloud. And sorry for the AI voice. It's not all 100% formatted properly. So, but if you want to read it yourself, just go ahead and go to the Theta website, and it's right there. Basically, I just took this whole PDF, I scanned it, and allowed the AI voice to read it. So sometimes when I'm working, I can research different blockchains, go to their website, look at their white paper, scan it, then it reads it to me as I'm working, so I can listen. But yeah, this is one of them I wanted to share. I thought, hey, let's just make a video. Let's do it. So yeah, definitely listen on your way to work, or I would definitely try to listen again, because there are things that I missed the first time. But take each paragraph and really figure out what they're saying in these documents here. But I think Theta, and now the introduction of Theta Edge Cloud is going to completely take it to the next level. I mean, it's right here. The first hybrid cloud computing platform built on a fully distributed edge architecture by Theta Labs, right? So increasing video demand globally, the adoption of AI across industries and applications, the infrastructure, compute services, right? It goes over the overview of the Edge Cloud, the product vision, right? What's their vision? The supported communicating task, right? And then it goes into the architecture, like the nitty gritty science, the nerdy part of it, right? So the architecture, the multi-shared architecture, shared management, task assignment, token rewards for edge nodes, right? And it talks about ThetaFuel, and basically the roadmap and different things, right? So yeah, it's really interesting what Theta has done so far and what they're continuing to do. Just real quick, the introduction once more. Theta Labs introduced the Theta Edge network and Elite Edge nodes in the spring of 2021. With the launch of the Mainnet 3.0 and with the launch of the Theta Metachain in 2023, became the leading decentralized Web3 video infrastructure basically on the planet. The vision was to build out a fully decentralized global edge network run by community members that would provide distributed computing. This is where it's at right here. So storage and delivery capabilities for video encoding, transcoding, right? Storage and peer-to-peer delivery. Elite edge nodes are staked, aka ThetaFuel, for uptime mining earned, you can get additional ThetaFuEL, right? So delivering higher performance with better hardware and software specs. With the number of partners in launching subchains in 2023, Edge nodes are now also compensated with partner TNT20 tokens for various videos and AI tasks. Theta Edge Network, with its more than 10,000 monthly active nodes, has become a key differentiator compared to the other L1 blockchains. So, I mean, put it this way. The Theta Edge Cloud is the next generation technology that builds on the Theta Edge network and Theta Metachain, significantly extending and generalizing its capabilities to become the first hybrid cloud computing platform that is built on a fully distributed edge architecture. Ladies and gentlemen, this is where fundamentals come in. This is where utility comes in. And this is where Web3 blockchain infrastructure for video AI entertainment, right? So here it is, right here, the Theta Edge Cloud. You can download the document that I was reading. But yeah, definitely go through their website, check out everything they got going. I might do another video if, depending how people take this, right? I might do another one, and I'll start here. Running a Theta validator. I might do a voiceover for this. And yeah, I like the AI voice type of thing where it can just read to me as I'm working, because honestly, who has time to read when everything is go, 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 right? So, as I'm driving, as I'm on the computer, I get to listen to it. So yeah, if I can put it in a package and put it out there online, then essentially I'm doing some of the work for you, because for those AI voiceovers, some of them you do have to pay for. But I think it's worth it, especially getting the utility part of this technology and really trying to understand it, because we get the idea: crypto, blockchain, decentralization, peer-to-peer, but there's so much more that we don't even understand and comprehend. And that's where taking a step back from the charts and from the price and really understanding these technologies can help further your confidence, your conviction of what you actually hold, and it makes it, for me, easier to hodl. So with that being said, I will catch you guys on the next one. Don't forget to like, subscribe, and leave a comment. Really appreciate it. And yeah, I will catch you guys on the next one. Cheers.